Good morning, children. This is 8th Standard Maths, Chapter 1 Cubes and Cube Roots. So, in your Part 2 textbook, this is Chapter 1 Cubes and Cube Roots. So, children, to understand what is cube and cube roots, let us consider some of the examples. Look into the first example, children. We have here 5 to the power 3. So, this 5 to the power 3 can also be read as 5 cube. So, now 5 cube means the number 5 has been repeated 3 times. That is the meaning of 5 cube. So, when we write this 5 cube as 5 into 5 into 5, we will obtain our final answer, that is equal to 125. So, the number obtained when a number is multiplied by itself 3 times are known as cube numbers. Therefore, this 125 is called as a cube number or perfect cube. So again I'll repeat, therefore the cube numbers or cube. So what is the meaning of cube numbers is that the number obtained when a number is multiplied by itself 3 times is known as cube numbers or perfect cube. Therefore, 125 is a cube number or we can call it as perfect cube. So consider the next example, children. We have 3 cube. Again, 3 is multiplied by itself 3 times. Therefore, the number we obtained, the final answer is equal to 27. That is, 3 cube is equal to 3 into 3 into 3. When we multiply, we will obtain 27 as the answer. And this 27 is called as cube number or perfect cube. So consider the third example in which we have 2 cube. So 2 is multiplied itself 3 times, 2 into 2 into 2, and the answer we obtained is 8. So this 8 is a cube number or perfect cube. Consider the fourth example in which we have 10 cube. So 10 is multiplied 3 times, 10 into 10 into 10, and the answer we obtained is 1000. So 1000 is a cube number or perfect cube. Therefore, from these examples, 125, 27, 8000, these are the cube numbers or perfect cube, and those are obtained when a number is multiplied by itself 3 times. So children, in your part 2 textbook page number 2, we have table 1 and table 2, in which in this you can observe from 1 to 10, these are the cube numbers. So 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125. In the same way, 6 cube will be 216, 7 cube 343, 8 cube is 512, 9 cube is 729, 10 cube will be 1000. In the same way, when you consider table 2, you have from 11 to 20 the numbers and the cubes. That is 11 cube, 12 cube, 13 cube. So when a number is multiplied by itself 3 times, you will obtain one number, and these are called as cube numbers or perfect cube. So from 11 to 20, you have the cube numbers such that 1331, 1728, 2197, 2744, 3375 for the 15 cube, and 4096 for 16 cube, 4913 for 17 cube, and 5832 for 18 cube, 6859 for 19 cube. So 8,000 will be for 20 cube. These numbers or these cube numbers or perfect cubes are obtained when we have multiplied the number itself by 3 times. So this 8,000 has been obtained when you multiply 23 times. That is 20 into 20 into 20, you will obtain 8,000. This is about cube numbers and how do we obtain cube numbers, children. Next we shall move on to exercise problems. Exercise 1.1, that first question, which of the following numbers are not perfect cubes? So, which are not perfect cubes? Perfect cube, we have studied a number which is multiplied itself by 3 times. Those are called as perfect cube. In the question they have asked which are not perfect cubes. So to understand this concept, let us solve the first problem, 216. The first problem is 216. To find out 216 whether it is a perfect cube or not, let us go by factorization method. So let us factorize 216 now. So we have 216. It goes by the least number, that is 2. So 2 ones are 2, 1 is lesser than 2, so take 0, then it will be 16. So 2 8s are 16. Again it goes by 2, 2 5s are 10, 2 4s are 8. Again it goes by 2, 2 2s are 4, 5 minus 4, 1 is remaining, 2 7s are 14. Now we have 27, then it goes by 3, 3 9s are 27, 3 3s are 9 and 3 1s are 3. So these are the factors of 216. Therefore in the next step, therefore by prime factorization, this is the factorization. Prime factorization means you can observe that 2 and 3, those two are prime numbers. Therefore, by the prime factorization, we got the factors of 216. Now, let us count the factors. 2 has been repeated 3 times. So, we will write it as 2 into 2 into 2 into 3 has been repeated 3 times. So, 3 into 3 into 3. Therefore, in the next step, 2 into 2 into 2. So, it is children 2 cube into 3 into 3 into 3. 3 cube. Therefore, if in the prime factorization of any number, each factor appears 3 times, then the number is a perfect cube. So in the prime factorization of 216, the factors 2 and 3 has been repeated 3 times. Then we can come to a conclusion that 216 is a perfect cube. So what is the question? Which is not a perfect cube? We have to find out. But we obtained in the first problem answer, that is 216 is a perfect cube because each factors have been repeated 3 times. Therefore, 216 is a perfect cube is the answer, and the method followed is this one. The second problem is 128. Now we have to find out whether it is a perfect cube or not. Therefore, let us first factorize 128. So when we factorize, it goes by 2. 2 6 are 12, 2 4s are 8. Then 2 3s are 6, 2 2s are 4. 2 1s are 2, 3 minus 2, 1 is remaining. So 2 6 are 12. 2 8s are 16. 2 4s are 8, 2 2s are 4, 2 1s are 2. Therefore, by prime factorization, this 128 can be written as all the numbers we have 2. So, 2 has been repeated 1, 2, 3, 4, 5, 6, 7 times. So, let us write it as 2 into 2 into 2 into 2 into 2, 1, 2, 3, 4, 5, 6, 7 times. 1, 2, 3, 4, 5, 6, 7. So we got 2 repeated with 7 times. Now we shall group these 7 into groups such that now, so we will take the group of 3 digits. That is since it is a cube, so 3 digits form one group. So 2 into 2 into 2. This is one group, so we got here 2 cube. Then into, go to another group, 2 into 2 into 2. Again we got 2 cube, but in the last group we have only 1 2. Therefore here 2 is left without making a group of 3. So, in such cases, when a number is left without making a group of 3, then 128 is not a perfect cube. In order to get a perfect cube, children, each factor has to be repeated 3 times. Therefore, 2 cube into 2 cube, and this 2 also should be 2 cube. But in this case, we have not obtained in a group of 3. That is, we have not got 2 cube. Therefore, we can come to a conclusion that 128 is not a perfect cube. So children, here 2 is left without making a group of 3. That means 2 is not multiplied itself by 3 times. Therefore, 128 is not a perfect cube. And this is the answer. The third question is 1000. Now we have to check whether it is a perfect cube or not. So children, by looking into 1000, we know that 10 cube is equal to 10 into 10 into 10, it is 1000. Therefore, it is definitely 1000 is a perfect cube. So, but we have to prove that 1000 is a perfect cube. So, to prove that, we shall go by factorization. So, when we factorize 1000, it goes by 2. So, 2 5s are 10, the other 2 zeros write as it is. Then try with the 2 again. 2 2s are 4, 5 minus 4, 1 is remaining. Therefore, 2 5s are 10, 0, 250. Again it goes by 2. 2 1s are 2. 2 2s are 4, 5 minus 4, 1 is remaining. So, 2 5s are 10, 525. Now it goes by 5. 5 2s are 10. 12 minus 10, it is 2 is remaining. So, we get 25. So, 5 5s are 25. So, it goes by 5. 5 5s are 25 and 5 1s are 5. Now, the next step, by prime factorization, 1000 can be written as 2 into 2 into 2. So, 2 has been repeated 3 times into 5 into 5 into 5. Again 5 is also has been repeated 3 times. Now let us form a group of 3. 2 into 2 into 2 it is 2 cube, into 5 into 5 into 5 it is 5 cube. Therefore each factor appears 3 times. The factors are 2 and 5. They have been repeated 3 times. Therefore 1000 is a perfect cube. So it doesn't come under non-perfect cube. It is a perfect cube. So this is the answer. Next it is fourth problem, 100. So let us check whether it is a perfect cube or not. First let us factorize 100. So 2 5s are 10, 0. Again it goes by 2. 2 2s are 4, 5 minus 4, 1 is remaining. So 2 5s are 10. So then it goes by 5. 5 5s are 25. 5 1s are 5. So by prime factorization, this 100 can be written as 2 into 2. So 2 into 2 into 5 into 5. 5 into 5. Therefore, group. Now 2. It is 2 square. Into 5 into 5. It is 5 square. So here, the 2 and 5 is left without making a group of 3. So 2 and 5 has been not multiplied itself 3 times. Therefore, we can come to a conclusion that 100 is not a perfect cube. So children, here 2 and 5 are left without making a group of 3 and hence 128 is not a perfect. Therefore, Therefore, children, 100 is not a perfect cube. So, 2 and 5 are left without making a group of 3. So, therefore, 100 is not a perfect cube. Then, 100 is a perfect square. Okay, so it is not a perfect cube because 2 and 5 are left without making a group of 3. So, 100 is not a perfect cube. So children, a number is called as a cube number or perfect cube when a number is multiplied by itself 3 times, then it is called as a cube number or perfect cube. And these are the answers.